Good day everyone, welcome to JD's channel. Today, we're going to discuss another topic. Don't forget to like, share, and subscribe for more tutorials. Thank you and God bless.
Good day, class. Welcome again to JD's channel. So, for today's topic, we will discuss all about nodal analysis. So let's get started. For the contents, we will discuss what is nodal analysis, nodal analysis with voltage source, case 1, nodal analysis with voltage source, case 2, and lastly, we will solve problems with regards to the theory of nodal analysis. For introduction class, having understood the fundamental laws of circuit theory like yung ating mga na-discuss na before, Ohm's law and Kirchhoff's law, we are now prepared to apply these laws to develop two powerful techniques for circuit analysis. So yun nga, yung una nating na-discuss is mesh analysis, which deals with which is based on systematic application of Kirchhoff's voltage law, or what we call KVL. And this time around, we will discuss all about nodal analysis, which is based on systematic application of Kirchhoff's current law, or what we call KCL. So what is nodal analysis? Nodal analysis provides a general procedure for analyzing circuits using node voltages as circuit variables. So, ayan. Ito nga yung analysis kung saan ang gamit naman natin dito is yung mga node voltages. Ano po? Choosing node voltages instead of element voltages as circuit variable is convenient and reduce the number of equations one must solve simultaneously. To simplify matters, we shall assume in this section that circuit do not contain voltage sources. So, yan yung ating i-assume in dealing with nodal analysis. Okay? In nodal analysis also, we are interested in finding the node voltages given a circuit with n node without voltage sources. Okay, so we are now proceed to the discussion of reference or datum node. Yan. Yung ating reference node or datum node. Okay. The first step in nodal analysis is selecting a node as the reference or datum node. The reference node is commonly called the ground since it is assumed to have zero potential. A reference node is indicated by any of three symbols in the figure in the next slide. Okay, so tingnan natin yung mga symbol ng ground na ito na ginagamit na nakalimit na nakikita natin at ginagamit sa mga design and also sa mga circuit na ganito circuit network. Ayan. So, the type of ground in B is called the chassis ground. So, ito po, tawag dito natin is the chassis ground, and is used in devices where the case enclosure, or chassis acts a reference point for all circuits. When the potential of Earth is used as reference, we use the Earth ground in A and C. Okay? So for our discussion, we shall always use the symbol in B. So ito po class ang ating gagamitin during our discussion. Ano po? Kaya yan, yung ating makikita sa ating mga circuit. Okay? So the next is, yan. So here's a note here. The number of a non-reference node is equal to the number of independent equation that we will derive. So maya-maya, tandaan nyo lang, class, na the number of non-reference node is equal to the number of independent equation we will derive. So maya-maya. And then, sa pag-derive natin ng equation, so ini-express natin siya in this way, wherein current is equals to the voltage of higher potential minus voltage of lower potential over ng R. So like Ohm's law, it's V over R. Yung flow ng current natin or the current natin, we express it in node voltages. So we use Ohm's law to express this current in node voltages. Ano po? Current flow from higher potential to lower potential in a resistor. Ayan. So, and non-reference node, okay, we simply set the voltage at the non-reference node equal to the voltage of the voltage source shown, ayan, in figure. So, ito katulad nito. Ang condition kasi dyan, class, ito yung ating voltage source, di ba? So, titignan mo agad kung siya ay in between ng ating non-reference node. Ayan. Siyempre, pag non-reference node, so hindi siya yung reference, hindi yung kinabitan ng ating ground. So, una-una, nagkabit tayo ng ground doon sa, kalimitan kasi sa baba yun dito lang sa baba. Kasi lahat dito nakakonekta ng branches. Kasi ang condition ng pag-create or pagpuput ng isang sa ground, dapat siya ay halos lahat doon nakakonekta. Okay, or karamihan and sa kanya nakakonekta. So that is why it is put here yung ground natin. Okay, so sabi daw doon, if the voltage source is connected between the reference node, which is itong baba, and non-reference node, we simply set the voltage at non-reference node, okay, non-reference node, equal to the voltage of voltage source as shown in figure. So, yeah, for example, V1 is equal to 10 volts. So, yan po. The next one, we will discuss nodal analysis with voltage source, case 2. Ayan, so may case na tayo. Sa case naman, it says here, if the voltage source, it's either dependent or independent. Again, class, it's either dependent or independent. Basta siya ay voltage source is connected between two non-reference node. Okay, so ito siya. And then meron tayong, ito ay V3. So hindi nakalagay kasi ito yung V3 and V2. Okay, those are the non-reference node wherein the voltage, the independent voltage, okay, or maybe if you encounter problem that is dependent source or voltage source yung nakalagay dito. So, ganun din, same din naman po ang procedure. Ano po? Ayan. The two non-reference node form, ayan, a generalized node or the supernode. Ayan. So, we apply both KCL and KVL to determine the voltage or the node voltages. Okay, so ito yung illustration nating class. Once na nag-ano na tayo. So, ayan yung mangyayari. Pag tayo nag-KVL kasi, yun lang part na yun ang i-enclose natin. Okay? Two non-reference node form a generalized node or supernode. So we apply both KCL and KVL to determine the node voltages. Katulad nito, nag-KVL tayo. Kasi ang mindset natin pagka nodal is puro KCL na lang. Ayan. So may nagkataon lang na pumatak siya sa supernode na problem or illustration. So a supernode is formed by enclosing a dependent or independent voltage source connected between two non-reference nodes and any elements connected in parallel with it. So, yun lang. Yung ating supernode, yun nga, discuss na natin. And then, also another one, supernode may be regarded as a closed surface enclosing the voltage source and its two nodes. Okay? Ayan. So, doon na tayo sa properties of supernode class. So, note the following properties of supernode. So, unang-una class, the voltage source inside the supernode provides constraint equation needed to solve for the node voltages. So, ano ibig sabihin nun? Ayan, yung daw supernode dun sa isang circuit, ano? So, nililimitahan yung ating mga equation or there's a constraint equation needed to solve the node voltages. Ayan. And a supernode has no voltage of its own. Ayan. A supernode requires application of KCL or KVL. So, KCL and KVL. Okay. So, the next one class is step to determine the node voltages. So, yan. Solve yung problem na. Ano. So, una-una is step to determine the node voltages. Select a node as a reference node, katulad ng ating nabanggit kanina. Assign voltages, V1, V2, and so on, kung ilan man ang iyong node. Okay, so to the remaining n minus 1 node, the voltages are referenced with respect to the reference node. Okay? So, ang pangalawa naman, apply KCL to each of the n minus 1 non-reference nodes. Use Ohm's law to express the branch current in terms ng node voltages. Okay? Thirdly, solve the resulting simultaneous equation to obtain the unknown node voltages. Okay, so that class, yung ating 3 steps in solving dito sa ating torsion. So, ito yung kanyang illustration. Again, select, una select, ayan, non-reference node. As mag-assign ka, and then, ayan. Pangalawa is mag-KCL ka and use Ohm's law to express the branch current in terms ng node voltages. So, express natin siya using yung ating Ohm's law. And third is solve the resulting simultaneous equation to obtain unknown voltages. Okay, so that is our concept or theory. Okay, so as you can see here, so nagkaroon na ng flow ng current class because yan yung magiging pattern kasi natin para malaman natin yung gagawing equation, and then pag nakabuo na tayo ng equation, we will convert it to node voltages. So mamaya makikita naman natin sa ating problem. So dito tayo sa problem solving. Ano po? Ayan, so here is your Here is the sample problem. Find Ix in the circuit of figure below using nodal analysis. Okay, as you can see here, class, medyo ano siya, hindi pare-pares ng unit. Merong may ohms, merong may Henry, farad, okay? Ayan, and Henry. So, ang tawag po class dito sa ating circuit na ito is yung ating time domain na circuit. This is the time domain. Okay. So, paano natin isusolve ito ngayon, class? Ayan. Sige, sulat muna natin. So, yung ating given circuit or write lang natin. Okay, so again, select a node as a reference node. So, nagkaroon tayo ng reference node na dito. And assign B1, B2 do sa mga remaining n-1 voltages. So, we have this B1 and B2. Okay. The node voltages are reference with respect dun sa ating reference node. Okay, so since magkakaiba sila class, so ang gagawin natin ay yan ay kasi naka-time domain yan. So we need to put those na nasa time domain to frequency domain para ma-solve natin yung problem. Ano? So from 20 cosine 40, so na-convert siya, given na yung ating omega is 4 rad per second. So we have 20 bar angle 0 degree volts, yung ating supply, and then yung ating Henry, 1 Henry, convert to, yun nga, yung ating frequency domain is equal to J4 ohms. So saan galing yung J4 ohms? As we can remember, class, we have the XL minus 2 pi FL, where also, pwede din yung ating omega L. And take note, it is positive because it is inductance, okay? So, let's continue. Ayan, so convert circuit from time domain to frequency domain. So again, yung ating Henry, 0.5 Henry, convert natin sa ohms, which is J2 ohms, and yung ating farad, 0.1 farad, convert sa ohms. So remember, yung ating X is equals to 1 over 2 pi F C, okay? Or also 1 over omega C. So it has the symbol or the sign negative, okay? So kaya naging negative ng ating negative J, 2.5 ohms. So let's put it in a circuit. Ayan. So ito po yung mag-itsura niya. Ano po? Ayan. Kung nakikita nyo, ayan yung ating mga flow ng current. Ayan yung ating ground. Okay, so sabay na rin yan. Ilagay mo na yung mga flow ng current mo kasi mamaya gagamitin natin yan sa ating pagbuo ng equation. Okay? Okay, now the next step is express or apply KCL to each of the n-1 non-reference node. So also use Ohm's law to express branch circuit into terms of a node voltages. So kanya meron na tayong current. So ginawa natin class is ilagay mo natin siya sa current. So let's say KCL at node 1. Okay, so nag-KCL. Ayan. So, unang-una is we put in this current equation. Ayan. This is in terms of current flow. So, yan, meron tayo yan. Ang kailangan natin gawin is express this equation into node voltages. Ayan. So the next is this one. So from our equation, I sub 1 equals to I sub x minus plus t sub 2. Okay. And then, substitute lang natin yung ating mga value. So, we have 20 bar angle, 0 volts over ng 10. And then, yung ating I, which is kung makikita natin yung circuit, is yung I natin talaga is V minus yung ating zero potential, which is yung ground. Ayan. Tapos yung kanyang dinaan na negative J 2.5. And also, yung I2 natin, kung check natin, ay tingnan natin sa ating circuit kanina. So, ayan, express na natin siya. So, we use Ohm's law, kaya naka-node voltages na siya. And then, we simplify, we will get this. At hindi lang yan natapos dyan. So, isi-simplify ulit pa natin using yung kanilang mga denominator. Okay, so yan. And pag na-simplify nyo yung last, ang lalabas na sagot dyan is, yan. So, yung ito equation 1 pa lang, So, 200 minus J10 plus 200 minus J plus J 15 times B V sub 1 plus ito ang ating negative J 2.5 or negative J 25 V2 is equals to 0. That is our equation number 1. So for equation number 2 class, so same procedure, nilagay muna natin yung current and then in-express natin in node voltages using Ohm's law. And then, sundan natin yung flow ng ating problem. So again, kuha natin yung ating yung denominator. Okay, same sila. And then express lang natin sila sa ganong solution. And sa dulo, magkikita tayo ng sagot na, ano sagot natin sa dulo? 11 VI plus 15 B2 V sub 2 is equals to 0. That is our equation number 2. Okay. And the third one. Yeah, so other equation. So we have two equations to unknown, so we can solve the problem, and also this other equation that we can use in finding the So let's now proceed to the so simultaneous solve for the resultant simultaneous equation to the unknown node voltages. So ayan, ang ginawa po natin class ito is nag-eliminate tayo, eliminate V2 using equation 1 and 2. And then so eliminate na yung eliminate itong J2, J25, tsaka yung ating 15 B2, okay? Eliminate na din to. And then magre-result siya dito. Okay, so 3,000 and then ito 0 and then ayan. Get 18 plus J6 volts for the V1. Okay. Solving for Ix, again, 18 plus J6 over na negative J 2.5. And then, ayan. So, ito na yung magiging sagot natin, Ix. So, please do compute din po. Ix is equal to 7.5894 bar angle. So, kung naman ito ay rectangular, so you can express it in polar. Ayan. Ganyan class, ito yung naka frequency domain. Okay, yung nakuha nating result. So, ibabalik ngayon natin siya sa time domain. So, ang nangyari lang. So, again, we get ix equal to 7.5894 cosine quantity 4 plus 108.4350 degree ampere. So, ayan yung ating sagot. Check natin kung tama yung ating sagot. Okay, 7.5894 cosine 40 plus 108.40 degree. So, ayan yung ating mga sagot. Okay, class. So, that would be all for the tutorial in nodal analysis. So, thank you. So, I hope that you get something and you learn something from this tutorial. And don't forget to like, share, and subscribe for more tutorials. So, thank you, class, and to God be all the glory. So, thank you and keep safe, everyone. God richly bless you.